Number 6 looks the most like an arcsine integral, like this form. Let's see, let's write this as 4 squared a squared, and let's write this as something squared. All right, so we end up with, underneath that square root, let's write 4 squared, so that we want a to be 4, and here e to the 4x, we want to write this as something squared. Well, that's e to the 2x squared is e to the 4x. All right, now again, this will only make sense if the derivative of e to the 2x is in our integrand. Well, the derivative of e to the 2x is e to the 2x times 2, and we do have e to the 2x here. So that's good. So we'll be able to do a u substitution. So that, well, this is what we call a typical u substitution, where we have the derivative of inside on the outside, and after the u substitution, we'll get something of this form. All right, so we want to do this u substitution. U is equal to e to the 2x. So du is 2 e to the 2x dx. And 1/2 du is equal to e to the 2x dx. Let me put my dx in here. Okay, e to the 2x dx. Let's substitute 1/2 du for that. And here we have square root 4 squared minus e to 2x, that's u, minus u squared. So now we have something exactly of this form. All right, so let's integrate according to this form. So we have, let's just have that 1/2 in front, and then we have arcsine u, which in our case is e to the 2x, over a is 4, plus c. In number 7, we're going to first complete the square. So let's do that underneath the square root. And when we complete the square, we want the coefficient of x squared to be plus 1. So let's factor out this minus, like this. So here we have x squared, and here we have plus 6x and plus 8. Okay, and let's start the process for completing the square inside parentheses here. So we have x squared plus 6x. Half of 6 is 3, so we're going to add 9, subtract 9, and then we have this plus 8 over here. Okay, this is our perfect square. This is in parentheses x plus 3 squared. So let's write that. Okay, so we have x plus 3 squared, and then we have minus 1. Minus 9 plus 8, so that's minus 1. And then multiplying through by that negative opening parentheses, finally, this is what we have under the square root. This turns around, and we have 1 minus x plus 3 squared. That's when we open up the parentheses. Now, this one looks like an arcsine. In fact, it's exactly an arcsine. Let's look at the arcsine form. So here it is. Here's the arcsine form. And in this case, a is 1. A squared is 1 squared. And here we have our u. U is x plus 3. All right, so let's just go ahead and integrate. So this is equal to arcsine. U is x plus 3 over a. A is 1 plus c. Notice we didn't have to do a u substitution. We could have done u equal to x plus 3, but since du would be equal to dx, no constant would come out, and that's why we didn't do the u substitution. Now 09 is different. It's not one of the inverse trig integrals. All right, it's simply a u substitution power rule. Notice that here we have an inner function arctan, and the derivative of arctan is on the outside. The derivative of arctan is 1 over x squared plus 1, and we have it right here. Right here we have 1 over x squared plus 1. So this is just a simple u substitution. All right, so we're going to put u equal to that inner function, and we have du in our integral. So now we're going to substitute for 1 over x squared dx. That's just du. And here we have u to the 7th. So this is just a simple power rule. And now let's substitute back. U is arctan. Number 9, I left out that dx. Number 9, we're going to split into two integrals. So let's start by doing that. Let's write this as x over x squared plus 25 dx, and then minus the integral of 1 over x squared plus 25 dx. Now this one is an arctan type of integral, but what about this one? Well, this is a different type. This is not an arctan. All right, this is of a log integral. Notice the derivative of the denominator is 2x, and we have an x up here. So this one's going to be a log integral. All right, so let's start with the first integral. Let's start with this one. We just put u equal to the denominator, and du is equal to 2x dx, or 1/2 du is equal to x dx. So we can do our substitution, and for x dx we put 1/2 du, and here we have 1 over u. So this is 1/2 log u, or 1/2 log x squared plus 25 plus c. So that's going to be our first one. And now let's go ahead and do the second one. So the second integral, let me look at that again, 1 over x squared plus 25 dx, and this is exactly an arctan. That's our a. A is 5. All right, so if we follow the form that we saw before, here we have 1 over a, that's 1 over 5. Arctan. U over a, u is x in this case, x over 5 plus c. All right, so our final answer would be this first one minus the second. All right, here we have this integral minus this, so our final answer is, let's combine the two integrals. So we have 1/2 ln x squared plus 25 minus 1/5 arctan x over 5 plus c. So that's it.